Okay, happy day, everyone. So, today, what we're talking about is what I would call an impure substance problem. So, I want to make sure that before we start this, you really have an understanding of what this problem is asking you to do. So, if you read a problem and it tells you that you have an or, and this really does bring in some like common knowledge, and this is going to be some of the major and key differences between AP chemistry learning at the college level chemistry versus a first year chemistry or an honors chemistry class. So now we want you to make sure that you're really thinking about what's happening and it's not just rote memory or just kind of doing a problem because you know you've done it this way before. So it's really thinking about the information that you're being given. So in this problem, they say that we have an ore of barium, okay? Now, when you go to mine something, and not that we're all in the realm of mining, but maybe you have just thought about, you want to go and mine some gold or you want some silver or something like that. So the question is, what does that take? Well, typically, when mining occurs, it is impure. The substance is not in its pure form. So you really need to do some different things in order to get it so that you just have that particular element that you were looking for. And a lot of times they're metals. And so in this case, in this kind of story problem, it says that we have an ore of barium that contains barium carbonate. So it's got other things in it. And they say that you take a 1.320 gram sample of it and they treat it with HCl. So immediately what I want to start doing is I want to start just jotting some notes down about what I'm seeing. And so I'm seeing that we've got some type of reaction, even though and I don't know that I necessarily need a balanced equation per se, but just to kind of get some of this stuff down. So I'm going to write down that we have this ore and it's some barium, and maybe it's some barium mixed with some other things. And it says that it's got some barium carbonate in it, for example. Okay. And so they tell us that we've got 1.320 grams of this particular sample. Okay. And then they say that we treat it with hydrochloric acid. So I'm going to say plus hydrochloric acid. And then it says it dissolves the BaCO3. The resulting solution was filtered to remove insoluble material. And then it was treated with H2SO4. So some stuff happened to it. And then we end up treating it with H2SO4. And after they treat it with H2SO4, they precipitate out BaSO4. So it looks like BaSO4 is one of my products. And so they specifically say that this is a precipitate, this barium sulfate. The barium sulfate was precipitate was filtered, it was dried, and then it was found to weigh 1.175 grams. And so what they're asking us is, what is the percent by mass of barium in the original sample? So they're saying inside of this thing that's impure, so this is our impure substance right here. So this is our impure substance right here. They're asking us how much of it is just barium. So we're looking for the percent of barium. That's going to be our final answer, is the percent of barium. Okay. Now, there are two ways that we can solve this. So one of the ways is using stoichiometry, which I tend to always feel like stoichiometry is easier. It's more fluid. You can kind of see where you're going. You circle what you want, write what you got, throw in your bridge, and then you're on your way. Whereas you can also use mass percents. So if you use mass percents, to me, it may make more sense to use that, but I think it may be easier to use stoichiometry. So let's start with the stoichiometry method, and then let's go back to the mass percents. Okay, now, I cannot use this 1.320 grams right now. The reason why I can't use it is because it's a mixture of stuff, okay? So I don't even know what's in it. They're saying that it's got some barium carbonate in it, but I don't even know if it's all barium carbonate. It's some ore, okay? So this, though, they said that they dried it and they precipitated it. So it's just barium sulfate. So this, if I can figure out, similar to when we were doing the CHO problems, if I can figure out the barium inside of the barium sulfate, then I can use mass percents. Or what I can do is use stoichiometry. So watch what happens with stoichiometry. Watch how it just kind of flows, okay? So I'm going to start with the 1.175 grams of this BaSO4. I'm going to throw in a bridge. And we all know anytime that you're in grams, we're going to switch our grams to moles. And this I already looked up was 233.39 grams per mole in the barium sulfate from our molar masses. Okay, so now we know I'm in moles of BaSO4, so I'm going to write moles of BaSO4. Well, something that we didn't do, I don't think we really did much of in the first level chem and honors chem, but in AP, we use this quite often. And it's basically saying it's a ratio. If I have 1 mole of BaSO4 and I'm trying to figure out how much barium there is inside of it, then instead of using mass percent, I can also use this method where I say, well, there's only 1 mole of barium for every BaSO4 molecule. So if it were sulfur, I would say 1, but if I were being asked for oxygen, I would say 4 moles of oxygen for every 1. So remember, a formula is based on formula is based on moles, okay? So that's according to moles. So now I'm in moles of barium, nice, and now I want grams. So I look up on the periodic table and the molar mass of barium is 137.33 grams for every 1 mole from, again, the molecular weight. So now I can multiply and divide, and when I multiply and divide, I get 0.6913 grams of barium. Okay, fine, but that's not what the question is asking. The question is asking, what is the percent by mass of barium in the original sample? Well, by the law of conservation of mass, I'm assuming, and the problem's kind of hinting that all of the barium is inside of this barium sulfate. Otherwise, they would have given other stuff, okay? And they didn't. So the assumption is that all of the barium is in here, which means if it's in here, then this must match the barium that's in here, because nowhere else in the treatment did we have barium. So all of the barium must be in this original ore. So that's my total mass. So what I'm going to do is I'm just going to divide by the total and get the percent. Remember, percents of anything, you always take X, what you're looking for. So I always say it's like what I'm focusing my eyes on to get my percent, divided by the total. So if I was talking about how many people were wearing hoods in the room, I would count how many people have hoods. Let's say it's 5 people, and then 30 people total in the class. I would divide and then multiply by 100, and that gives you your percent. Otherwise, you have a fraction, okay? So I'm going to divide by this 1.320 grams total. This is the impure stuff that has barium in it. Multiply it by 100, and that is going to give me my percent, which ends up being 52.37% is barium. Okay, so that's one way to solve the problem. So now what I'm going to do is I'm going to show you another way of solving the problem, just like we had said. Instead, we're going to use mass percents now, okay? So again, I would have the problem set up the same way here, and so now I know that barium sulfate is my set, that's my set precipitate. So again, like I said before, if I can figure out how much barium is in here, then I could essentially figure out how much barium is in here. Okay, so let's do, and remember, percents are always the same. It's just a matter of how much of it that you have. So let's figure out the percent using the periodic table. So again, for barium, my molar mass of barium I have here is 137.33. And that's grams per mole of the barium. I'm going to divide it by the molar mass of barium sulfate. So that's right here. So that's 233.39 molar mass of BaSO4. Again, the reason why I can do this is because I know it is all barium sulfate. And so then I can multiply by 100 to get a percent, but really I do want to work with a fraction, so I could stop there. It ends up being 58.83% is barium inside of barium sulfate, okay? So now, but that's not here. I first need to know how much barium is inside of here so that I can use the law of conservation of mass to match it there. So I'm going to use point, shift my decimal 2 loops back, multiply by the total mass. And so now I'm going to multiply by this 1.175 grams in the barium sulfate to find out how much of it is barium. And when I multiply that, I get 0.6914 grams is barium in the barium sulfate, which means that must be the amount of barium inside of this stuff here. So all I'm going to do is divide that by my total, which is 1.320 grams total. And this is my impure stuff again. And multiply it by 100 so that I can get a percentage. And when you do this, you get 52.38%, which is just about the same. We're off a little bit. 0.01, no big deal. I think it's just sig figs. And so those are two different ways on solving an impure substance. Again, it shouldn't really take you more than like 2 or 3 minutes. I think the big thing about doing these problems is that I had to explain a little bit, and that's where our video being 10 or 11 minutes ends up coming. So please make sure you keep watching these, because my idea is that you get a good understanding, a good background, and that you're really learning from it. Happy day, everyone. Hopefully this helps you out.